Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Hey there, it's been a couple days. All of a sudden we got something to talk about. Welcome, Meteorologist Tuttle, back with you again. It is about, I was going to say 6:14, but that's the date on the calendar. Come on, brain. It's 9:40. It's almost 10 o'clock. It is June 14th, though, and we got severe weather to talk about for June 15th, which is tomorrow, in which case we'll be dealing with damaging winds, large hail, and yes, I actually think we'll have a couple of tornadoes here across Oklahoma to speak of. So thanks for joining. That's what tonight's forecast is going to be focused on. So thanks for joining me. Make sure you like and share this video. Tell your friends and family about AT's weather. Go ahead and hit the share button. Send a text. Send a quick phone call. Whatever you got to do. Say, hey, he's on. He's going to talk about tornadoes. Whatever you want to do, spread the good word. So I appreciate you guys doing that for me. And that way we keep this page going and this broadcast going organically on all the social media accounts for YouTube, Rumble, and Facebook. I'm going to post a link on Facebook. So if you do get trouble going or getting notified when you go live, make sure you opt in with that link I just posted. And that way you don't miss a broadcast. And I will show up in your DMs right before I do go live. That way you got plenty of time and you won't miss a thing. Okay, so let me see. You guys on YouTube are already checking in and rock and rolling. Good to see you. Everybody's in the house. Excellent. Of course, Miss Jody is on the keyboard, so she'll be keeping you guys company here for tonight. And as always, thanks to you guys on Rumble. And if Gab ever gets their act together, we'll be live on Gab at some point soon. And, of course, Facebook as well. I see you already throwing at the stars. Thank you, Christine. I appreciate that. I always appreciate the stars you guys send on Facebook and also on YouTube, where you can do the Facebook or super chats and some other things. And Rumble, I think, does Rumbles. I don't know. Everybody's always got some kind of platform for their content creators. So not just me, but if you watch anyone online regularly and you do appreciate the content that they produce, just make sure you give back to them in some fashion. That way that rewards their time and efforts. Well, out there currently, we had a really nice, quiet sunset. It was actually pretty decent evening. I mean, I've got 76 degrees at my backyard, so it's cooling down nicely. Winds are pretty calm out there. If you would like to get a weather station like I have, it's the Tempest weather station. There's a little picture of it right there on the left, a promo code AT's weather. And actually, there's another promo code here just for Father's Day. It should be posted on my wall. I don't know if Jody, if you did that or not, but there's a code on the wall that gives you just an extra few bucks more off for my Facebook page. It should be posted on there. If not, I will add it after this broadcast once I check in to make sure. But anyway, you can scan that QR code and that'll take you to the website, and you can order one as well for Father's Day, right? It's a pretty good gift for old dads out there. It beats a tie. Maybe dad's tired of ties. Maybe he's got enough ties. Maybe he opens up that closet door and it's nothing but ties. Well, this time around, give him a weather station. All right, so let's get on with the program here, shall we? Here is a look at the high temperatures for today. We're into the 80s. Do I see a 90? I'm looking. Oh, way down in southwest Oklahoma. There was one 90-degree temperature to spoil all it takes is one bad apple to spoil the bunch. The rest of us were in the 80s, even some 70s out there, the Panhandle. Now, currently, we're back into the 60s and 70s. Like I said, a really nice evening. And the wind's pretty much negligible, very light out there from various directions. Rainfall amounts over the last couple of days, pretty heavy in far southern Oklahoma. Around Durant, Ardmore area. Here's some little colors on the map, which indicates 4 to sometimes 5 inches of rainfall. Otherwise, you can see a lot of green here, which is anywhere from 1 to 4 inches in some of these areas. Little break in the action, once you get north of Oklahoma City up to around Stillwater, not a whole lot up here in this fashion. But once you get into northeastern Oklahoma, things got a little bit better, and also way out into the Oklahoma Panhandle. Now, we're going to get more rainfall for tomorrow, west to east. Now, I will say, kind of the same idea. We'll focus most of the rain kind of, in this fashion here, the western quadrant, and then it'll kind of weaken with time once it gets in this area, and then maybe some other overnight stuff kind of clipping northeast Oklahoma. So this little section right here, I'm afraid, may be in a repeat performance of not as much action. Now, if you do look at the severe weather threat, believe it or not, we're actually talking about that again. So let's take a look here for tonight, tomorrow, or really overnight. It's going to go out here in southeastern parts of the country. And then for Thursday afternoon and evening, right here over the greater state of Oklahoma. On Friday, that shifts to the northeast, kind of clips the northeastern part of Oklahoma and otherwise Arkansas. And then on Saturday, a little batch here. Now, this is probably going to be redrawn on Saturday, just to let you know. Atmosphere is quite potent with instability, so this little circle here may move around a little bit or expand. So kind of gives you an idea that, yes, we are under the gun for a little bit in the way of severe weather. So let's talk about tomorrow. That's what you're here for. Okay, so what's causing it? Let's take a look at the jet stream pattern, the upper levels of the atmosphere. Again, the colors represent lift and spin. In other words, that's the stuff that we get the storms to form on. And so you'll focus this little area down here. Of course, there's one up here, it's not going to bother us. There's one here kind of anchored to our east that'll cause that stuff tonight, and then up here to the northeast. And in between, we have this little ridge up across southern Canada, which has actually caused them to bake in the heat up around Winnipeg. They had a nasty early start to their summer. Kind of got a double area of high pressure they're trying to build. So what happens is, I'm just kind of quickly drawing this on the fly, but the jet stream kind of flows in between these lines, right? And you kind of get one that comes up here over the ridge, and then back down here over the trough, and that heads that direction. Again, you have a flow that also comes around this ridge in this direction, and you have a little bit of a split flow that comes around this guy, and he kind of comes into this direction. So this is kind of the river of air, how it flows around these little upper level features. So what we're going to focus on is this guy right here. It's going to kick out this little strong guy right here. This is going to come out to the east. So as we step this through motion, watch those brighter colors enter the Texas and Oklahoma Panhandle by Thursday afternoon. So this will be our kicker to get these severe storms to form. Now you do notice there's other areas out to the west. So we're still stuck in a pattern, which, believe it or not, is providing us additional showers and storms. So the rain is not over with, thank goodness. And if you remember my long-term forecast for the summer, it should not be over with anytime soon. We are kind of in a different pattern this year with the El Nino coming back. Let's see. Here is the Saturday. Here's the Saturday storm system. So again, a nice little trough axis right here with the next upper level disturbance. This is all lift out ahead of it, coming into the state and across into Kansas. We'll see how far south it goes and how much of an influence that'll have. But for weekend plans, just keep in mind, for Saturday evening, we'll probably have some thunderstorms to deal with. That may be severe. Okay, so now let's talk about some of the other things going on. And we talk about instability, we talk about lift in the atmosphere, we talk about some other ingredients like shear, moisture, all that kind of stuff. So we put it all together in a magic basket. And this basket of ingredients is where we really focus on the strongest of the strong when it comes to potential for tornadoes. So where is that focused on? Well, tomorrow afternoon and evening, it is focused in this little section here of kind of the southwestern quadrant of the state. Now, this is just the peak of the data. In other words, it can still expand out of this little zone just a little bit, but we're just kind of taking a snapshot in time. And if you look at various places on the map, southwest Oklahoma, for example, this is going to be the Altus area that I'll click on. Just kind of give you some ideas, because atmosphere, of course, was fluid, so it's just a snapshot, and which may or may not exactly look like this, but this is going to give us an idea what we're looking at. So what we have is a potential possible hazard type of a tornado. We have a pretty good hodograph shape. We have really good shear, which we normally don't get this time of the year, is both in speed and direction. So it starts out the surface at southeast and then kind of tilts to a westerly fashion. So that means that will help to spin the column of the air in the atmosphere in the thunderstorms. Let's see, the profile sounding is significant of classic supercells. If a tornado were to develop in this environment, this little red line over here takes in the whisker plot boxes up around an EF3 to EF4. In other words, it's just saying that's how potent the atmosphere is, because it has Cape values up around 4,500, 4,600 joules per kilogram. So, in other words, off the chart instability with the shear present, big storms, should a tornado form, it could be quite significant. And again, that's not something we normally see. I will say this, there's a caveat here. We do normally say our severe weather season, when it talks about tornadoes, runs from roughly mid-March to mid-June. So March 15th to June 15th, technically, it's in the ballpark, it's in the window. It's just it's been so quiet lately, and we didn't have much action in May like we normally do. This is going to be kind of a rude awakening for a lot of people. But anyway, that action area is still focused here over the western half of the state. It does kind of come into central Oklahoma a bit during the evening hours. All right, so temperatures tomorrow, I'll show you in the afternoon, right around 4 o'clock. So temperatures down here will be in the mid-90s. So that'll be what breaks the cap. So temperatures don't only need to be in the low to mid-90s here across western southwest Oklahoma and the eastern Texas panhandle. You can get away with it into the upper 80s. So it should be no problem breaking the cap. So it'll be a warm and humid day for tomorrow. Like I said, we've got the instability. So if you look at the shear and cape overlay, all these little vectors here, you see nice little triangles on the map. That indicates that the profile is nice and rotating with height. And these little values down here, the cape values up around 5,000 joules per kilogram. That's just ridiculous instability. How much instability do you need for tornadoes? Believe it or not, you only really technically need like 1,500 if you have adequate shear. If you have like ridiculous shear, you can get away with like 500. But on an average, 1,500, 2,000 is plenty, and we've got up to 5,000. It's obviously a little lighter up here in the Oklahoma City metro area, but it doesn't matter if any storms are in this environment. They'll continue to rock and roll for a while until well after dark, in which case, as usual, they lose a little bit of that daytime heating and they do start to slowly weaken. All right, so let's take a look at some of the model output. What is going to happen? Okay, so there's going to be some different approaches here, and I can't really tell you which one's going to be right because they're all in the ballpark. Each of them have their strengths and weaknesses and how they think the atmosphere will evolve. But here's at 4 o'clock in the afternoon. All right, so it's got this little favorite hot spot down here in southwest and over here into the Panhandle region, this particular model. Now, as we go into the 5 o'clock hour, 6 o'clock hour, it kind of keeps this focus going down here in southwest Oklahoma. It likes to blow up this activity here in the Panhandle as it breaks the cap. And then these storms move eastward into western Oklahoma. You see these little trails here? This is the helicity tracks. So in other words, this means there's plenty of wind, rotation, and hail within these. And in some cases, there may be a tornado given the right conditions. Now, what we call the cloud bases of these will probably be a little elevated, a little high, which may help to offset the tornadic development. In other words, they may try really hard, but that may be a limiting factor due to some moisture that's not in certain levels that we need for a lot of tornadic activity. So that's slightly going in our favor. Not to say it's going to stop it all, but I think at least help to eliminate a lot of what probably could have happened if we had just a little bit more moisture mixed in the lower levels of the atmosphere. So we have one ingredient that's not quite all the way there, but the rest of them are. All right, so here's 9 o'clock. This model continues to focus these storms moving through the I-35 corridor, but you can see how they weaken. All right, this is a completely doable outcome. I'd be completely on board with this, totally fine. This would make sense. It'd be normal. Things usually weaken, as you head toward 9 and 10 o'clock. Then you get like some elevated stuff that develops usually like around midnight hour, and that can move into southeast Oklahoma during the overnight period. A lot of weaker though storms. In other words, there'll be some lightning, maybe some small hail, but nothing like the ones from earlier in the day. Okay, so that's how that one runs. Let's take a look at this one. All right, this is our supposedly best short-term high-resolution model. The problem is it likes to get a little excited sometimes, not all the time, but sometimes it likes to overpromise, and it often underdelivers. But this is what's going to happen. It thinks that we're going to have several supercells break out here in western Oklahoma by the 5 and 6 o'clock hour. It's got even one out ahead of the curve out here across the Clinton area. But as we head into 7 and 8 o'clock hour, you can see how they march through the body of central and western Oklahoma. And so it does move the Oklahoma City metro area. So if you have any plans across the greater Oklahoma City area after 7 p.m., you will have storms approaching from the west to deal with. And there will be some big storms with some hail and some damaging wind. Will we have the tornado threat by that point? It's tough to say. With the weakening trend a little bit in that fashion, and the cap building in at that fashion at that time, I would really like to think that the tornado threat would lessen quite a bit by the time it got to the metro. It would hang on probably just until it gets here, and then it kind of diminishes. That's usually how that happens. But this particular output still keeps it going in southeast Oklahoma overnight. There's a 10 to 11 o'clock. Ardmore, some big storms down there. Get some hail makers. And there's midnight, 1 o'clock, 2 o'clock in the morning. So again, this is a pretty robust output. We will go to the new, let's see, is this model even in yet? Not yet. 2 o'clock stops there. Okay, so I'll come back to that one here in a minute. What I do want to focus on, if, again, we get that more of that widespread look and severity of the storms, I want to show you the potential is when it comes to the wind. Okay, so little pockets of wind, like this right here, says 81 miles per hour. This is the model's doing its best bet, taking samples of the atmosphere of what it can produce with a storm interacting with it. It's got a lot of 60 to 70 to 80 mile per hour winds through western Oklahoma. Once it gets into central Oklahoma, remember I talked about how they'll have a tendency to collapse and die out? Well, that means all that momentum, that air, that energy that went up has to come down. So what happens is they decay, they dump. They dump some serious downburst winds with them. All right, so in other words, this particular model, as it comes in Oklahoma City, says we may have wind gusts up around 88 miles per hour. Just in this one instance at 8 o'clock in the evening. It's just one example. There's little pockets down here. Here's some 70s. This is probably on Chickasha, point south and east. And then we'll go to 9 o'clock. If you look here, 85, 86, 89, 88. Look down here, 105, 106, 117, 119. Now, come on. Now, this it's going to be a little overdone. But the take home is that you could probably have winds of 90 miles per hour, straight line winds, doing a lot of damage down here in south central and east central Oklahoma as this line collapses. Now, this is in favor of that more robust line, 8 to 9 and 10 o'clock. And then here's up around 10 and then forward, still up around 100. And it says 114 miles per hour. That's just a random spot I picked on the map. Same thing up around McAllister. So again, southern and eastern Oklahoma may get some ridiculous amounts of wind up through midnight as these storms continue to slowly collapse across this area. Now, you don't typically see winds over 100 in a large, prolonged event, just so you know. So model's going to hint that it's possible within this line, but it does not indicate or mean that it will be that way the entire time. Just means that that's what potentially is on the table. So keep in mind, someone's going to get it. It may not be a lot of people, but someone's going to get those type of winds. Not quite, probably over 100. I could go with the 90s because you have to subtract a little bit from friction and other things that happen. So usually you never get quite tap into that raw data. But I want to stress, we've got the wind in addition to baseball-sized hail. So that's the other avenue we'll be dealing with. And that can include the metro Oklahoma City, points west and south. Again, in these big storms, the biggest storms will have the biggest hail. The rest of you, it'll vary from quarters, dimes, nickels, golf balls. That'd be more commonplace. But some, I'd say quite a more than some, is probably going to get some significant hail. Hen eggs up to around baseballs. Okay, so rainfall amounts. Models try to do a good job at estimating what potentially can come out of the liquid equivalent of a thunderstorm. In other words, these heavier storms that do move through. This particular model, for example, just shows these tracks up around. You can get some potentially brief flash flooding of around 2 inches in this time frame. So let's see, let's go to that one. Here's the other model that had a little bit more widespread action with it. It has pockets up here around 3 inches. Here's 3 inches. Here's 4. Down here in southern Oklahoma, there's 4. So there you go. You can get some brief flash flooding with that as well. Okay, let me see if that other one was in. This was the newer data. No, it's slow. I will show you the prior run, just kind of give you an idea. Now, I don't know how well it does in the summertime spring blends. I have noticed in the summertime, like in the last few weeks, kind of a deal, it's been way overestimating stuff. It's gone a little too crazy. But this is what it looks like for tomorrow. Now, it likes this southern and southwestern Oklahoma section right here from around Lawton and points east. Its secondary areas up here along the I-40 and points north. All of these have little helicity tracks with them, meaning some damaging winds and hail. Again, potentially tornado or 2. Here's 8 o'clock, 9 o'clock. Again, heavy storm coming in the southwest side of Oklahoma City. But you can see the severity kind of limited. You see a lot less of those helicity tracks once it gets east of I-35 up here. Now, the exception to the rule is down here. It looks like there's still plenty of instability to go, whereas up in this part of the state, not nearly as much instability. Therefore, the storms continue to kind of weaken. So that was the older data on that. All right, let's tell you the temperatures. We're at about a rain-cooled, well, I'll say rain-cooled, a residual from the overnight rain and some clouds, etc., and probably a little bit of a weak wind shift. So in the mid 80s on Friday, so not bad. Saturday up around 90, where we basically should be. Sunday, same idea as what Friday is after a big storm system, that little weak disturbance, usually a little bit of a light wind shift, which helps to bring in some slightly cooler air. It's hard to say cold air because it's the summertime, so you don't get too carried away. I will show you or mention though that I discussed this in my blog. It was yet to be seen if our extended temperatures are going to be getting into those mid to upper 90s. I didn't really want to buy it because there's too much model discrepancy between the global models. The American, the GFS model, was the one that was going nuts with 100 degrees and 110 degrees. I mean, it was dumb. It was never going to pan out. But it was just to show you what if a ridge could build over here on top of us, like it suggested, what was on the table. But you still have to evaporate all of the recent rain we've had, and you have to kill off the vegetation that's grown as a result. So that model usually errs big time when it comes to putting up those ridiculous numbers. So this looks more doable for the pattern that we're in, which is pretty close to normal. So we'll have low 70s in the morning and low to mid 90s in the afternoon. We're not going to quite shut off the rain just yet. So that's what I have you. So if you're late, you're just tuning in, you missed it. Well, let me do one thing for you. Let me load this thing up again. Let's see. Control, paste. Hit that link, and that way you won't miss it. It's on Facebook Messenger. That way I can get into your DMs and tell you, hey, I'm about to go on live broadcast, so don't miss out. All right, and that way you'll be late. So we'll do that. And then I do see some comments and questions in there, so I'm going to get to that here in a second. Just keep in mind I can't read any of those, while I'm going live because I'm looking at maps and stuff. Just, FYI. Dave on YouTube, by the way, thank you very much for the gift. I appreciate that. So, all right, here's the deal. So the atmosphere is potentially loaded with 90-plus mile-per-hour winds as these storms have a tendency to collapse once they get past the 9 o'clock hour across central and eastern and southern Oklahoma. When they're out in western Oklahoma, they're going to have some pockets of wind up around 70. It's more typical, maybe to 80. Very small, isolated areas versus a large or widespread area. Secondly, hailstones. There'll be a lot of different hail sizes, all the way from the small to the very large. So we're talking baseball size in the data. Now, I've seen some, analogs that go back and they have like 4-inch size hail, which is, we're approaching up to around grapefruits or something. Now, sure, it's possible you're going to get a random, super ridiculously strong storm that could have a few hailstones up around that size, but those would be more on the outlier, right? Those are few and far between. Baseballs is big enough. That's destructive enough. You don't need anything bigger than that to do destruction. So, but that's what we're going to be looking at for tomorrow. That can include here in the metro, pretty much anywhere you're going to have these big storms. Okay, so we got the damaging wind, and we've got the big hail. Now, tornado threat. Where's it at? Well, right now, best data shows that it's going to be across the western half of the state with a tendency to weaken and diminish as we get later in the evening and closer to the Oklahoma City metro. So in theory, you could have a potentially tornadic thunderstorm that would or could produce a tornado up until it gets probably like toward the El Reno area or maybe or down toward Minco or Tuttle, something like that, and lifts, and then that's the end of it. So that is potentially on the table. Usually that usually plays out quite a bit when the storms come in, kind of late, when the cap builds in and everything else. So that's an outcome that can occur. Now, we do have in the atmosphere the lowest levels. We do have some moisture because we have Cape values up around 5,000. You need surface moisture for that. You don't have a whole lot of the surface to mid-level moisture, though, that I would like to see for a much easier tornado threat. I see it helping to kind of limit that a little bit. So I do think we'll get a couple of tornadoes. I don't think we should see a lot of tornadoes, if that makes any sense. Now, the couple that we do get probably be pretty significant. So it could be an EF2, EF3. The model data had as high as EF4. A lot of times the models, though, they overestimate on that kind of a deal. To get those really strong and violent ones, you usually have to have some type of boundary interaction. It's rare just to have an EF4, EF5 occur without some type of surface boundary to help boost the vorticity in it. It's just very difficult to get. They're very rare anyway. So I usually keep that off the table unless I see a surface boundary to work with, which is not around tomorrow. So EF2, EF3, as a result, is probably good enough. Now, with that said, if you've never been here before, you're visiting, or you just moved, or whatever, a couple things. One, get my weather app, AT's Weather to Go. It predicts the tornadoes ahead of time, gives you more time to seek shelter. You're like, how does that happen? It's got AI in it. So it's an early precursor to what the dirty word everybody's using now. Basically, it's just smart computer language that says, hey, we're going to look at this all these ingredients, and we're going to assign a value to it and go, yep, looks like this is going to produce a tornado, and give you a confidence scale from like 1 to 10. So if you get a BTI number that's around a 2 or 3, it just means the storm's rotating, heads up, there's spin in the atmosphere, but it's not going to produce a tornado yet. If it goes to a 4, 5, or 6, it could easily produce one, and then once it's a 7, 8, 9, or 10, it's producing one. So that's kind of how you gauge the numbers, which means you hit the deck accordingly. If it's a 4, 5, or 6, I'd go ahead and hit the deck anyway. There's no need to procrastinate. If it's a 7, 8, 9, don't even think about it. Just go first, and then you can look at data and stuff later. So that's how you would use those numbers. But anyway, the point being with that is always go into the center part of your building, whether it's a home or office space, whatever it may be, the most center part of the building, away from all outside walls and windows, because you want to protect yourself from flying debris. And with tornadoes, again, they'll usually take out the outer walls, and sometimes they'll take out the corners of the roofs. Same thing for homes. Weak spots, weak links are the eaves, the corners of the house, in addition to like the garage. So it's usually where the engineering destruction starts to happen internally, which then kind of cascades a little bit. Now, with an EF2 or EF3 tornado, you're in a well-built, according to structure code homes, you don't have really anything to worry about. The homes will hold up just fine with those type of tornadoes. It's those EF4s and 5s the ones that no matter how well you build a home, there's not much left of them. But even when that happens, you can still survive it. But point being is most of our tornadoes are in the EF0 to EF1 category, about 75% of them. Hey, it's a pretty good number. All right, so most of those are in those categories, and I call them baby tornadoes because they're more of a nuisance thing. It's not a threat as long as you've got plenty of adequate shelter. Even a mobile home will hold up to an EF0. EF1, it'll probably flip the home, so I guess you could be injured if you're inside the home. But as far as destruction like that, that's going to take an EF2. But when it comes to well-built structures, again, you're going to have to get at least an EF2 to get minimum damage. EF3 to get enough to even notice, where maybe you're missing like half a roof or maybe an outside wall, but the rest of the structure is still intact. That's kind of how that goes. So I kind of break it down for you that way you know how things look. And then the other thing is, when I do go live tomorrow to cover the storms, what we'll do on radar is what I always like to do is, okay, so let's say there's a tornado. Everybody's jumped up and down, hooting and hollering, right? And they're all making a big deal about it. They go, oh my gosh, it's a tornado. Okay, two things. One is the size of a tornado is typically very, very small. Usually a few hundred yards to maybe a quarter or maybe even half mile. They're very rare to get bigger than that, all right? So it's like a needle in a haystack. Secondly, I hate to say it, but a lot of time, guess where these occur? Over open farmland, no farmhouses, no nothing. Sometimes not even a twig. So, especially out in western Oklahoma. So what we do is we take the radar, we take a look at it on the screen, and I remove the radar off the screen so you can see what's under it. So when you see what's under it, you're like, ow, it's over a wheat field. Literally. Like there's nothing anywhere around. Phew. You know what? All of a sudden, what happens to your anxiety? It goes down. It's not sexy. It's not Hollywood. It's not going to get your emotions all worked up. You're going to be like, well then who cares? So I'm going to be on the who cares side of things if that's what happens. Now, if it turns out it's going to be going into an area that's obviously more populated, we'll do that too. And that way, you know, if you know people that live in a neighborhood that it's going into, you can give them a heads up, you can give them a call. We do a street level mapping, track street by street, intersection by intersection to find out where it's at and where it's going. So all that kind of stuff. So if you've never watched my live coverage, that's how I kind of approach that area. And then I talk you through the storms. I tell you what it's doing, why it's doing it, if it's going to produce a tornado or if it's going to weaken. I don't use a bunch of fun, fancy terminology that you may hear elsewhere of made up terms because they're all made up. They weren't in textbooks when I was in college. People excited have to name something, so they just name things and it sounds really fun and cool and geeky, and so they go with it. And that's fine. It's whatever. You're going to get that in the storm chasing community, so because everything has to be named, right? So I might throw in some of those terms and other terms I may not, and I don't know if I really need them. So basically my focus is, all right, where is the tornado and where's it going, and how strong is it, and then who's the threat down the road. So that's it. I keep it real simple, really straight, And Jeff, Bill Paxton's brother. So that's kind of how that goes. All right. Let's see. That other model, let's see, real quick. For these folks that are still with me, let me see if that other model came in. And so I'm kind of curious just to see what it did. It's our experimental one. So it's the one that we're supposed to be going toward. No, it's stuck at the same hour. So lame. Let me see if I have another source for that. If I do, I'll show it, but I gotta go pull it up. So let me see here. All right. Hold that thought. I'll be right back. No, it's not going further either. Main. Okay. Oh, that's all right. Okay. Let's see. Okay, so you had some questions. Somebody asked about Dallas. Was it Jared? Was that you? So let's go see. All right. Let me go pull in the HER. Because there was a cluster of storms down there in the Red River Valley. All right, so there's a few storms around, supposedly, this evening, overnight, mostly east of you, though, eastern Texas. All right, so here we go. There's a big cluster up there. It misses you at midnight, and it slams northeast Texas. All right. Oh, it's got some stuff blowing up way down there around Waco, College Station. Home of my fighting Texas Aggies. All right, let's check out another one. All right, now this one takes a different trajectory. This is the first one I looked at earlier this evening because it liked that southwestern quadrant of Oklahoma. And I said, just like I said the other one, this one has just as much validity as potentially being accurate. When you're looking at the model data, you can't get too specific on it. You just know that the storm's going to be out there. You know the area. As far as the exact tracks, that's silliness at this point. But regardless, this particular track has it going through around 9 o'clock. For you guys, it'd be some hail. What that looks like, a little bit of a hail track with it. Let's see if I don't know if this is gonna give me good data. We can see here. It still likes a potential tornado type hazard. Let's see, what time is this in the day? Oh wow, so it has a low cap. So according to this model, would have a chance to keep going. And also, this has more moisture here in the lower levels than we did in Oklahoma and western Oklahoma. So this would have an easier time to produce a tornado, in my opinion, based off the fact we have better moisture here. So again, if this model pans out, you'd have to watch out for that potential here in the Dallas-Fort Worth area as these storms approach from north and west tomorrow evening after about 8 o'clock. So we'll see what happens with that. All right. So that's a good question. And then we're going to pull up this guy here. I didn't look at this earlier, but just curious. So this loves the whole light them up. Just light them up, light everybody up. Northwest, West Central, and then North Texas and Central Texas. So there's your Dallas-Fort Worth around 7, down to Waco, Oklahoma City, points west with Felicity tracks with all these. So this is a pretty volatile outcome. All right, that goes through the evening hours, and it's out of the state by midnight. Okay, let's go to some of these other cams. All right, so this one also favors kind of the southwestern quadrant, but it moves it more east than south, loves this northwestern quadrant. It seems like the models are kind of split. They're in two camps. It's either just a line all the way down, or it's a cluster here and a cluster here. Let's see. So there's, in the evening, just kind of clips the north side of Dallas-Fort Worth. Otherwise, Oklahoma City and points north, and there's a little cluster of south central Oklahoma during the evening. So similar, but not quite the same. And then more stuff there in southeast Oklahoma as well. And there's northeast Oklahoma there. All right, let's go one more, and that's really all there is to show you because we looked at all the data by that point as far as outcome goes. All right, this idea, again, it loves the southwestern quadrant of the state. Moves it closer to Dallas by 7. There's stuff here in central and northwest Oklahoma. Let's see, by 8 o'clock. So it does move it through Dallas versus the other one that kind of clipped the northern end. The stuff weakens as it gets into central Oklahoma. Then a little redevelopment down here in southeast. And that's it. Oh, I got it. Excuse me. I got an M&M in my throat. A peanut. There was a residual. I inhaled it. That was not good. That's going to make it difficult to talk. All right. I'm going to choke it over here. I'm going to get some water. All right. So anyway, that's it. Before I pass out, I will do a live at lunchtime tomorrow around noon, and we'll see if anything's changed. I don't think it will. Maybe we might be able to detail the split, if it'll be more of a line versus, a section, northwest, southwest, and then maybe isolate in between. We'll see if we can't narrow that down a little bit better, since that was the discrepancy for tonight. Otherwise, the take home is it's going to happen, and you're going to have all three potentially there. So you're going to have that large hail, damaging wind, and a tornado here in Oklahoma in mid-June, June 15th. So that is it, my friends. So thanks for tuning in. Again, like and share this video. Tell your friends and family about AT's weather. And I will see you soon. Again, don't forget to get my weather app, AT's Weather to Go. And thanks again for your donations and your support here for tonight. I appreciate that. All right. We'll talk to you next time. Good night.